Okay, now we're going to look at what elements do you normally see in a simulation system. Okay, so any simulation software. Okay, um, then we will look at Pro model specifically. So in general, if you take there are lots of different uh, software packages available early on, 30, 40 years ago when I was in graduate school. We had what is called GPSS, general purpose something something simulation system, I guess, general purpose simulation system, and that's what I learned simulation with. And at that time, it was all line by line coding. Um, but now we have object-oriented software packages, which makes building models so much easier and so much fun and easy to understand. So the object-oriented packages, okay, normally will have these four basic components, and then there is lots of other bells and whistles added on. So all software packages, all simulation software packages will have these four basic components. So you'll have entities. So entities are the items that come to the system or enter the system, go through the system and undergo some sort of change, and then exits the system once all the process is completed. So it can be, some examples are like it can be a human being, like a customer, patient, passengers in transportation. So human slash animate. Entities could be that, or entities could be inanimate. It could be parts. It could be raw material coming in, or it could be documents. Um, uh, and those are inanimate entities that we may simulate, or it can be intangible. It may not have a physical shape, so it will be like telephone calls or emails and internet packages that go through the internet and so on. Okay, so those are some examples of entities. The second component in simulation is activities. The activities are the tasks that are performed in the system. Okay, and the activities are performed upon an entity. So if it's a customer comes in and a service is provided to the customer. So that will be an activity. And to provide that service or for that activity to happen, some resources may be necessary. So activities may use resources, and there will be a passage of time. A given activity takes a certain amount of time. So how much time does it need? So that would be uncertain or a variable time. Okay? So here are some examples of the activities. So entity processing, like check-in. Customer come in into a hotel and they check in. Right. So there are patients come to a clinic, so they check in, and then there is treatment, inspection of parts. That would be something, and fabrication of parts. Okay. So those are entity processing activity. So then there are activities that will be movement. Okay, so you have entity come in, and then they move from one area to another area. So that also takes time. So resource movement. It could be entity movement or resource movement. So maybe there is a forklift and then a worker. Okay, so the worker is an entity, and the worker, or it could be a worker, could be a resource too. So worker is a resource. One resource picks up another resource, which is a forklift, and then moves it to a different place. So entity resource movement is an activity. Entity processing is an activity. Then resource adjustment. Okay, so you have a machine. Before the machine starts production, it needs setup. So that setup time, okay, setting the machine up, that is an activity. And maintenance and repair, that again is an activity. So these are examples of activities. Now resource are needed for performing activities. So you may not need to model resources for all activities. Okay, so if there is a dedicated resource which no other uh, uh, entity needs, then you don't have to simulate that. Okay, if you have a shared resource, okay, that can, that one uh, activity needs and there is another activity, then we'll have to wait for the resource to become available. So in those cases you have to define a resource, and these have characteristics such as, a resource may have a capacity, it may have speed, it may have cycle time, it may have reliability, so the resource may go down, may become unavailable for a period of time when it gets repaired and things like that. So examples, if you have human and animate, meaning, resources that are human or animate resources, that will be like an operator, machine operator, a doctor, a nurse, a bank teller, a DMV clerk. All of those will be resources, right? Animate resources. Inanimate would be equipment, forklift, tools, and things like that. And intangible could be information. Okay, so there may be some information that may have to come from certain sources, and only upon the receipt of that information, a particular activity may be able to, we may begin a particular activity. So that will be like an information, and power would be, approval of something. So that could be an intangible resource that we may deal with. We may have to model those. And then the fourth element of a simulation system is controls. Okay, control would be how the entity gets, the flow of entities. How do they make a choice to go one way or another? So there may be routing. So does the entity take route A or route B or route C or what? So controls how and when and where activities are performed. So production routing is a typical example. So you have work schedules for workers going from one machine to another machine, and then we have task prioritization too. So if we have lots of orders coming in, there may be some priorities in the order. So some orders may have higher priority than others. So that is sort of a control. So when there is a waiting line, and in the waiting line you have say 10 orders, then the waiting line may not be, the queue arrangement may not be first come first served. So it could be based on priority. So task priority is another way of implementing control.